As we delve deeper into the mysteries of the universe, scientists continue to explore and uncover new theories to explain the fundamental workings of the world around us. One such theory that has been gaining attention in recent years is string theory, which proposes a new way of understanding the nature of matter and the forces that govern it. At its core, string theory suggests that the fundamental building blocks of the universe are not particles, as we once believed, but rather tiny, one-dimensional strings. These strings vibrate at different frequencies, which give rise to the various particles and forces that we observe in nature. The origins of string theory can be traced back to the early 20th century, when scientists first began to explore the nature of subatomic particles. Over time, researchers discovered that these particles had strange and unexpected properties, such as the ability to exist in multiple places at the same time and to behave like both particles and waves. As scientists grappled with these unusual phenomena, they began to explore new theoretical frameworks that could help to explain them. One of the most important of these frameworks was quantum mechanics, which provided a new way of understanding the behavior of particles at the subatomic level. However, while quantum mechanics provided a powerful new tool for exploring the universe, it also created new questions and puzzles that remained unanswered. In particular, researchers struggled to reconcile the strange, probabilistic behavior of particles at the subatomic level with the more deterministic, rule-based behavior of objects at the macroscopic level. This led to the development of new theories, such as superstring theory, which proposed a new way of understanding the nature of matter and the forces that govern it. At its most basic level, string theory proposes that the universe is made up of tiny, one-dimensional strings. These strings are incredibly small, with a length of around 10 to the power of -33 centimeters, which is much smaller than the scale of individual particles. Despite their tiny size, however, these strings are believed to have an enormous impact on the behavior of matter and the forces that govern it. This is because the strings vibrate at different frequencies, which give rise to the various particles and forces that we observe in nature. In string theory, there are two basic types of strings: open strings and closed strings. Open strings are like tiny pieces of string that have two endpoints, while closed strings form a loop, like a rubber band. One of the most important features of string theory is that it proposes the existence of additional dimensions beyond the three that we are familiar with. Specifically, string theory suggests that there may be as many as 11 dimensions in total, which can be difficult to imagine and understand. One of the most fascinating implications of string theory is that it provides a new way of understanding the fundamental nature of matter and the forces that govern it. Rather than treating particles as fundamental building blocks, string theory suggests that they are instead made up of tiny, vibrating strings. This has important implications for our understanding of the universe, as it suggests that all of the particles and forces that we observe in nature are ultimately derived from the same underlying framework. In addition, string theory provides a potential solution to some of the most vexing problems in physics, such as the unification of quantum mechanics and general relativity. This is because string theory provides a framework that can potentially unite these two fundamental theories into a single, cohesive whole. However, while string theory is a promising area of research, it is still a relatively new and untested theory. As such, there are many questions and puzzles that remain unanswered, and scientists continue to explore and refine the theory in order to gain a deeper understanding of its implications. One of the major challenges of string theory is that it is notoriously difficult to test experimentally. This is because the strings themselves are incredibly small and difficult to observe directly. Despite these challenges, however, researchers have developed a number of different approaches to testing string theory and exploring its implications. One such approach is to look for evidence of supersymmetry, which is a key prediction of string theory. Supersymmetry proposes the existence of a set of particles that are related to the known particles in our universe, but with different properties. While supersymmetry has yet to be directly observed, researchers are continuing to explore new ways to test the theory and search for evidence of these elusive particles. Another approach to testing string theory is to look for evidence of extra dimensions beyond the three that we are familiar with. This can be done by observing the behavior of particles at very high energies, where the effects of these additional dimensions may become more apparent. While there have been a number of experiments and observations that suggest the existence of extra dimensions, there is still much that remains unknown about their nature and properties. As string theory continues to be explored and refined, researchers are hopeful that it will provide new insights into the fundamental nature of the universe. One of the most exciting aspects of string theory is its potential to unify the various forces and particles that we observe in nature. By providing a common framework for understanding the behavior of matter and energy, string theory has the potential to solve some of the most vexing puzzles in physics. However, there is still much work to be done before string theory can be fully understood and tested. While it is a promising area of research, there are still many questions and uncertainties that remain. Nonetheless, the exploration of string theory and its implications is an exciting and important area of research that has the potential to revolutionize our understanding of the universe. In conclusion, string theory is a fascinating and complex theory that proposes a new way of understanding the fundamental nature of matter and the forces that govern it. While it is still a relatively new and untested theory, researchers continue to explore and refine the framework in order to gain a deeper understanding of its implications. As we continue to explore the mysteries of the universe, string theory will undoubtedly play an important role in shaping our understanding of the fundamental nature of the world around us.